So function notation is our next topic in this section. We read this y equals f of x. And of course the variables can differ, x and y. It can be different letters. F could also be a different letter. F is just used kind of like for a generic function. It stands for function. Okay. So f is the name of the function. If you take higher level math classes, they might have three different functions you're working with. They might call one f, one g, and one h. That would be pretty common. They could also use a Greek letter phi. That's this letter here. That's a Greek f, phi. This is psi, which is another Greek letter. It's used a lot for functions. And there's other Greek letters that are used as well. This is a log, L-O-G, logarithm. We'll see that later in the course. That's the name of a function. So you'd have log of x equals y, right? This ln is a natural log. We'll see that as well. exp stands for exponential. We'll see exponential functions, but we won't use this notation exp of x. That's used mostly by engineers. So if you become an engineer, you'll see that a lot. And then these are some trig functions which we're not doing in this course. Sine, cosine, tangent, inverse sine, etc. So these are all names of functions that could take the place of this f. That's why I have them all in purple. They replace the purple thing. Okay? So let's look at what the separate parts are. This x in here is called the first coordinate of your function. It's called, the variable x is called the independent variable. And if you plug in a value for x, that's usually called the input. It can also be called the argument. However, argument has a slightly different meaning. If you just write f of x, the argument is x. But if you wrote f of x squared, for example, then the argument of f is whatever's inside of f, which whatever you're applying f to, which in this case would be x squared. The x would still be the input, but the argument would be x squared. So I hope that's clear. If not, then when I use argument in the future, hopefully it'll become more clear what I mean by argument. So y is the second coordinate, and as is f of x, because f of x equals y, it is y. It's also called the dependent variable. If you plug in a number for x and you get a number out for y, that number you get for y is called the output. Okay? So in general, we think of x values are inputs and y values are outputs. And f is we think of it as taking inputs to outputs. You plug a number in for x and you get a number out for y. Note that function notation is sometimes used for relations that are not functions. So just because we're using function notation doesn't mean it's actually a function. So you'll get some questions sometimes. It'll say, is this a function? And students will look and say, oh, there's an f, so it must be a function. So they'll say yes. That's bad logic because they'll use f even if it's not a function. Okay, so here's an example. It's just because it's useful because you can name different relations that way. So you could have an f relation, a g relation, etc., where they're all given by formulas. So here's an example of f of x equals plus or minus x squared. That is not a function. Because if I plug in 2 for x, I get plus or minus 4. Right? Just plug it in here, 2. That's 4 plus or minus 4. So the input of 2 corresponds to 4 and minus 4, and that's not a function yet, that the input going to exactly one value. So the plus and minus is what messes this up. So it's not a function, but I could still write f of x equals plus or minus x squared, and it still makes sense.